You're watching Power Nation.
Today on Engine Power, we check out a brand new aftermarket and affordable small block Chevy block and use it as the foundation for a sweet street build.
We're building the iconic 427 cubic inch displacement in a small block platform. And today we kick off the build with all kinds of tech. Hey everyone, welcome to Engine Power. You know, when we talk about engines, there's always these numbers that invoke horsepower in our brains. Probably our favorite is 427. 427 cubic inches is a legendary cubic inch number that has had great success in a couple of different manufacturers, both on the street and at the racetrack. But typically those are big blocks. They weigh a lot and take up a lot of space. But with modern times, it is easy as ever to pack that many cubic inches into the size of a small block cylinder case. So today on a very special episode, we are going to build up a 4 1/8 bore 4-inch stroke engine that runs on pump gas that makes great power on that old school 427-inch number.
This is going to be a ground-up build with completely new parts, and the foundation of that is going to be Summit Racing's new SPC Street Performance Competition small block Chevy block. Now, this is a serious aftermarket piece, and we have Brian Nutter from the product development team at Summit Racing to tell us all about it. So, Brian, go over some of the features of this block and why it's a little bit better than using a stock block in an application like this.
Sure. I mean, we all know that, factory block, they're very hard to find. Heck, they were hard to find 20 years ago. Good luck finding a 400 or something big bore that is remotely straight. We are Summit Racing. We've been in business since '68. We invest heavily in our customer base to make sure that they've got stuff to hot rod and race for the foreseeable future. We think in terms of decades. And we've got 5 different small blocks right now. One of the ones that you're playing with, we've got 4-inch bores, the 4 1/8. We've got 1-piece rear main seals, 2-piece rear main seals. So we may or may not have some big blocks on the way and Windsor stuff on the way.
This is a finished machine block except for the bores, correct?
Right. We're big made in America people. This block cast in Germany, finished over here in the USA. In fact, my home state of Nebraska. And it is just absolutely phenomenal in terms of the specs and tolerances. They're super tight. The only thing we didn't do with these blocks is finish the bores. And the only reason for that is you're going to pick a piston and it may be a couple tenths big, a couple tenths small. We don't know quite for sure. But you also have different applications, whether it be street, marine, land speed, drag, circle track, all different things. So you really do and should set up at your local machine shop for that. Other than that, you're really set to go with these blocks.
This block is hyper accurate. Yeah, because we've already been doing some preliminary measurements on it. Once that's done, this thing is ready to assemble and you are good to go.
It's very true. It is the most accurate block on the market. It's actually made of class 35 cast iron. So we've thrown the kitchen sink at it, everything from the oiling, the water jacketing, all of that's improved. We know that you're going to have a fun time building this.
Yeah, I mean, we're really excited for not only this build, but to use these in the future, because I think it's going to be a great option for not just now, but 5-10 years from now for people trying to build engines. So we got a ton of work to do on this. I think we're going to get started and get it on the dyno as soon as we can. We'll send you some pictures.
So excited for your project.
We have moved over to our Sun and SV15 cylinder hone to show you basically the only operation we have to do on this block, setting the final bore size to accommodate our piston. Our mains are torqued up. We have an ICT billet torque plate on with the correct gasket. Not only are we going to show you how to size it properly, but we're going to show you how to set the correct cylinder finish for our application using a couple different grit stones. And we're going to measure it very precisely with our profilometer setup and our Trace Boss software that we partnered up with Total Seal piston rings. To achieve the correct surface finish for our application, we use a process called plateau honing, which uses a rough and fine grit abrasives in stages. First, the rough abrasive, which in our case is a 150 grit diamond, is used to set bore geometry and remove material to get it very close to our final size. This also leaves a finish resembling a mountain range, with deep valleys, which our VK value represents, and tall, sharp peaks, which gives us our RPK value. Then we switch to a finer abrasive, for this application a 600 grit diamond, and run the hone for only a few strokes at a much lower load. This effectively knocks off the peaks of the mountain and provides a smooth plateau for a great lower friction load-bearing area for a ring, which represents our RK value, while still retaining the deep valleys that hold oil to lubricate and seal the ring. This provides a modern finish that will break in immediately and seal the cylinder excellently and have a long life.
Our Sun SV15 cylinder hone makes it extremely easy to achieve this plateau finish, and with only 5 thousandths left to hone to get to our final bore size, it won't take very long either. You've seen us dress the hone abrasives with a dressing stone, and this simply removes any block material from the stones to make sure we are creating a consistent surface finish between each cylinder. Once we switch to our fine abrasive and set our final plateau hone finish, we will thoroughly clean each bore like we would for assembly and take a measurement with our profilometer. All right, we've gone ahead and got our 427 block out of the hone, ran it through the parts washer really quick just to get some of that honing oil off of it, and we moved it to the assembly area to put it into mock-up mode, because with our 4-inch stroke crankshaft, we know we're gonna have some interference between the rod bolts and the oil pan rail. So what we've done is we put the crank and number 1 and 2 rod and piston assemblies in just for mock-up. And if we turn the engine over, you can see pretty clearly that the rod bolt runs right into the oil pan rail, and we've gone ahead and center punched where the center of the rod bolt is, and we've done this on both sides for the number 1 and 2 rods. Now, we're going to show you how to do this like you would at home. We could put it in the mill and get it done really quickly, but if you're at home, you can just do this with a carbide bit and a die grinder. But instead of putting all 8 rod and piston assemblies in, what you can do is take a set of dial calipers that are set to our bore spacing, 4-inch, 400 thousandths, and we'll take them and line them up on our first mark, and then we can use them to scribe where the next rod bolt is going to be on the block. We'll do this down both sides of the block for all 8. Then we'll go back and center punch our scribe marks, and that will give us a clear indicator of where the rod bolt is going to interfere. What we'll do is we'll pull the crank out, pull the rods and pistons out, go through and clearance each location, and then we'll put it back in and make sure it works. We'll use the biggest carbide bit we have to remove a substantial amount of material that will give us a minimum of 60 thousandths of an inch of clearance. We not only have to clearance the oil pan rail, but the bottoms of the cylinder as well, and we can use our reference marks to help center the notch. It will take a while to do it by hand, but if you take your time, you can get a great result. All right, several hours later, we have notched every single cylinder on our block, and we've also gone ahead and final cleaned it just to get all the metal shavings out of there. We have mocked up our crankshaft and rods and pistons again, and looking at the number 1, we have plenty of clearance, but our layout method across the block actually worked really good as well. So if we look at the number 8 cylinder, we can see we have plenty of clearance between the block and that rod bolt. So we are good to go. The next thing we're going to do is get this out of here. We'll get the block painted before we start any assembly. All right, we're taping off our 427 here to get it ready for paint. We thought this would be a great opportunity in today's Summit Tech Tip to talk about some technical taping tips, because we always get questions about how our engines look so good, and it really comes down to attention to detail. So when we are taping it off, the first thing we're gonna do is take some lacquer thinner on a rag and wipe down anywhere the tape is gonna stick, because we wanna make sure that there's no oil or anything like that on there, because the tape is not gonna stick, and then it'll be blowing off when you're trying to paint it. So we'll just go ahead and get it nice and clean. And then when we're laying our tape line, you probably think we're just gonna run it right out to the edge of the machine surface, but we're actually gonna go inside of that. And we usually like to go a little bit inside the gasket, whether it's the intake gasket, head gasket, whatever, because we want it to have full coverage once the cylinder head is bolted on with the gasket. Because any bare or exposed metal, once you assemble the engine, is just gonna rust. So we actually want the paint to go a little bit inside that. That way it's nicely covered. This will also make it easier for the paint to stick to the edge out here, because if you try and butt it right up there, it's probably gonna chip off pretty easily. We basically do this for the entire engine, and that way we have nice crisp lines. It's very neat, very organized, and that way you have a good paint job the next time you're trying to paint your engine. All right, we've got our engine into the prep booth and it is ready to go. We're gonna be painting it with P.O.R. 15 engine enamel, because we wanted a paint that was gonna be really, really durable under the hood of a car and have a nice glossy finish. And that's where P.O.R. 15 checks the boxes on our engine enamel. We have used this stuff a ton, as you can tell by the cans, and it works awesome. It is extremely durable to things like gas, oil, brake clean, and even lacquer thinner. We've spilled all that stuff on there and it holds up great. Now we've gone ahead and prepped the engine with their cleaner degreaser and their metal prep just to make sure we have a good surface to start with, and we're going to be coating it with their rust preventative. As for color, we're going to be making up a custom color because we like interesting engine colors around here. We're going to be mixing a set of Ford blues and a white to try and get a lighter blue, maybe even a baby blue. Once we get to that stage, we'll see what we come up with. But first, we got to get our base coat down, so let's get to work.
P.O.R. 15's rust preventative adheres to the bare metal surface, and that means we can have an even base color. So our engine enamel looks consistent throughout the engine. All of our P.O.R. 15's engine enamels are mixable, so a fair bit of white with a small amount of Ford corporate blue gives us a baby blue color that is unique to this engine. With it reduced down and in a spray gun, a few medium coats gives us an even coloring of blue and a glossy finish that will last the life of the engine.
All right, now that we have our engine painted, we're going to go ahead and let that cure. We moved everything over to our balancer so we can balance our crankshaft. So this is going to be one of the last things we need to do before we can move on to assembly. The crank we're going to be using is a 350 main 4-inch stroke scat unit from Summit Racing Equipment. Connected to that is a set of Summit 6-inch long H-beam rods. Those are going to be hooked to a set of Summit Racing Forge Pro pistons with a 4125 bore for a small block Chevy. These also have a slight dish to them, which is going to be great for a pump gas friendly compression ratio. They come with a set of heavy duty wristbands and the support rails, so we'll have to factor those into our bob weight. We have the correct set of rod bearings, we have the retaining clips for the wristbands, and we have our set of Summit Racing gas ported piston rings. So we can go ahead and get our bob weight set. We'll get the crank in and get it set up, get our first spin, see how we turn out.
Each of the components gets weighed individually, and then bob weights that simulate the rotating and reciprocating weight are mounted with the CWT's specific bob weight spacers to each journal pair before we do our first spin.
Spin her up. That's quite a lot of imbalance, which not a big deal. We have a really light piston, so didn't expect it to be that much, but that's not too bad. Looks like they're both on the counterweights, which is good. 224 grams on the rear and 128 on the front. So what we're going to do is we're actually going to use the CWT software. It will calculate how much we need to turn off the counterweight in our lathe. So we'll get that done, figure out how much we need to take off, and then we'll get this thing out of here in the lathe and start cutting. Using our MSC lathe, we can turn approximately 200 thousandths off the front and rear counterweights, which allows us to remove a large amount of material without excessively drilling holes and weakening the crank. With our crank back in the balancer and our imbalance much less, we can use a 1-inch diameter step drill bit from CWT's Randy Neal to fine-tune the imbalance before we do our final spin. Spin her up. Okay. That looks good. Both of our planes are within our balance tolerance, and they are 158 degrees apart from each other. That's pretty close to 180 that we target, so we're going to go ahead and save that as our last spin, so we have an updated version. But we want to talk about what that balance tolerance actually means and what the number means, so that is going to be the subject of today's Summit Racing Tech Tip. When we balance a rotating assembly, what we're trying to do is have equal mass on all parts of the crankshaft, usually between the counterweights and the rod and piston assemblies, so one doesn't have more mass than the other and causes a force that tries to pull the crankshaft in one direction or each other. And the way we measure this is usually in ounce inches. So this is a measurement of force, so how many ounces at a 1-inch radius, but it's kind of like torque, so as you move that radius farther and farther away from the center line, the amount of force actually goes up for the same amount of mass. The reason this is important is because it causes forces on the crankshaft and we want to minimize them. So our machine here will actually calculate the amount of force. So before we even started touching this crankshaft, if you had tried to put it together and run it, it would have 1,770 pounds of force at 6,000 RPM. We now at 6,000 only have 8 pounds of force, which is totally reasonable for a street engine. And that really shows why this is so important to get your stuff balanced. And Summit actually sells balanced or unbalanced rotating assemblies, and you can talk to the experts over there to figure out which one is right for you. As far as our assembly, we're really happy with the results, so we're gonna get this off, get our machine cleaned up, get our crank polished, get it cleaned up, and then it will be ready to go into our engine. You know, we don't do a lot of imports here in Engine Power, but that does not mean we don't get excited when some really cool advancements are made for these small displacement engines. And one of the biggest in the last year has been Dart's new cast iron aftermarket 2JZ engine block. Now, they have done a ton of work to make this a much better option than the factory blocks. And if you are looking to make big power with these engines, they are rated for up to 2,000 horsepower, and they have a ton of cool features to make that possible. Starting from the top down, they have improved deck thickness for improved sealing with head gaskets. They have the 11mm head studs as an option, or you can get bigger half-inch head studs like this one has. They have a max bore of 88mm with a cylinder wall thickness of 290 thousandths at that max bore. They have made all the core plugs and oil gallery plugs screw in, so you have easy serviceability for the block. Underneath, we are dealing with 4-bolt billet main caps on 1 through 6, and the number 7 main just has 2s. That way you can use a stock rear main seal, but these have 12mm inside fasteners and 10mm studs on the outside. But they have added a ton of material to the main webbing as well, again, for that improved rigidity under high horsepower applications to make sure this thing is going to live. They also have priority main oiling, they have improved cylinder cooling around the Siamese bores, and a ton of other features. But if you are looking to build a high horsepower 2JZ, this block needs to be the one that you look at.
With the paint on our block fully cured, the next step in the build process is gapping our Summit Racing gas-ported ring set. Using our Summit Pro ring filer, we'll set the second ring gap at 28 thousandths and the top ring gap at 25 thousandths, just in case we ever decide to put a power adder on this combination. With all the parts final clean, we can also start setting up our main bearing vertical oil clearance by torquing a new set of Cleveite extra clearance bearings into the mains. After using a micrometer to zero our dial bore gauge to the main journal size for each main, we can directly measure the oil clearances individually, and they are all between 20 and 24 10,000ths. One of ARP's specialties are rod bolt manufacture, and they make them out of a variety of different material depending on the application. Our rods have an upgraded bolt made out of ARP 2000 material. That is a high strength alloy that has a lot of the same characteristics as 8740 chromoly, but is able to be heat treated a bit differently, so it raises its tensile strength to 220,000 PSI. For what we're doing on our pump gas street hydraulic roller, our ARP 2000s are going to be perfect. Now, not only does ARP manufacture the fasteners, they also manufacture a great way to measure the rod bolt stretch. Rod bolt stretch is the best way to optimize your clamp load and durability of your fastener. So they manufacture their own high quality rod bolt stretch gauges, both in an analog style regular dial gauge, but also a digital gauge, which has an output if you want to output that to a computer, if you have that capability. So all we have left to do is get our bearings put in our rods, lube up our rod bolts with some ARP Ultra Torque lube, get them torqued up, and start measuring.
After loading the Cleveite rod bearings into the Summit H-beam connecting rods, we can torque the ARP bolts to 70 pound-feet to achieve the proper stretch. Then, similar to the mains, we will set our micrometer to the size of each journal and use that measurement to zero a dial bore gauge. Then we can take a direct reading of our rod bearing vertical oil clearance, and with them all set between 22 and 24 10,000ths of an inch, they are ready for assembly. Our forged pistons are from Summit, and they have a pump gas and even boost-friendly 18cc effective dish and a 1.2 3mm modern ring pack. With a compression height of 1 inch, they pair perfectly with the Summit H-beam rods that have a 6-inch center-to-center length and bushed ends. Plenty of Hot Shot Secret assembly lube is used when putting them together, and wire locks retain the heavy-duty 150-gram wrist pins.
Our freshly cleaned rings can then go on. Plenty of Total Seal assembly lube is worked into the ring grooves and used to coat the skirts for proper lubrication on initial startup. Now that everything is prepped, a coating of Hot Shot Secret Lube on the bearings and a small amount of RTV on the edges of our rear main seal set up a perfect home for our crankshaft to be laid into. From inside out, the main bolts are torqued to a final value of 75 pound-feet on the 7/16" inner fasteners and 35 pound-feet on the 3/8 outer fasteners. With it installed for real, our crank thrust end plate comes in perfectly at 3 thousandths.
The next piece is our retrofit hydraulic roller cam, which is a Summit Racing Pro SBC billet grind that has an LS firing order. Its durations at 50 thousandths lift are 248 on the intake and 256 on the exhaust, with the lobe set on a 110-degree lobe separation angle. Lobe lift is 367 thousandths on both lobes, but with our 1.7 ratio rockers, that comes out to 624 thousandths net lift at the valve. The rest of the Summit billet steel double roller timing set can go on with ARP cam bolts. Every cam here in Engine Power is degreed, and to make it easy, we'll only install the #1 piston and rod assembly, which allows us to find true TDC on our degree wheel. On this street rod application, we set the intake center line 1/2 degree advanced.
109.5.
Perfect.
The remaining 7 pistons and rods can be installed with this ARP 4125 bore, tapered ring compressor, and a Summit Racing piston installation dead blow. The rod caps are temporarily tightened down while we rotate the engine and get all the assemblies in the block. Then we can turn the engine upside down, loosen the rod bolts, and torque them to 70 pound-feet to achieve the proper stretch we measured earlier.
Now this is a ground up build, and we've already got a forged rotating assembly in the engine and painted obviously an unconventional color. So if you're not familiar with why this looks like this or how we got it here, here's a quick look at the work we've done so far. This is a new build using Summit Racing's aftermarket SPC small block Chevy block, and everything is precisely finished machined except for the board. So the first thing we did was put it in our Sun SV15 cylinder home. After setting bore size, geometry, and surface finish correctly for our 4125 bore application, we gave the block a quick wash and mocked up the rotating assembly. This block has clearance for a 3750 stroke, but with our forged 4-inch stroke crank, we had to do some minor clearancing for the rod bolts on all 8 cylinders. Then we final cleaned the engine block and got it ready for some rust protection and color using a custom mixed P.O.R. 15 engine enamel in a color we consider baby blue.
After balancing the crankshaft on our CWT Multi-Ball 5500, we could set up our main and rod bearing clearances, assemble the pistons and connecting rods, install the Summit gas-ported rings, and start the assembly process. The cam we spec'd out for this street engine has specs of 248, 256 at 50 for duration, with 624 thousandths valve lift and a 110-degree LSA, which we set the intake center line to 109.5 for a 1/2 degree of advance. After installing all the rod and piston assemblies and torquing up the bottom end, we had built ourselves a solid short block assembly ready for anything.
The first thing we'll do today is start sealing up this engine with the Summit Racing polished aluminum timing cover that will hold our cam button in place and one of their 6 5/8 harmonic dampers. Using the proper tool is critical to prevent damage to the damper during installation.
After flipping the engine over, we can install a Melling high volume oil pump, and it is held in place with an ARP oil pump stud that gets torqued to 60 pound-feet.
Now that we have our oil pump and pickup bolted on, we're going to do something we do on every engine, and that is measure the oil pump pickup clearance between it and the pan itself, and we're going to show you how to do it in today's Summit Racing Tech Tip. The 2 things we need are a straight edge of some sort. This is a calibrated one, but you can also use a level or something like that, and a regular old tape measure. So the first thing we're going to do is take our straight edge and set it across our oil pump pickup, and then we're going to measure down to both oil pan rails on the block on either side and average the 2 numbers. So on this, we're looking at 6 and 11/16 as our block measurement. So we'll take both of these and go over to our oil pan, and we're going to basically do the same thing. Set the straight edge across the oil pan rails and measure to the bottom of the pan. And we're looking about 6 7/8. So in our case, we have a really nice 1-piece oil pan gasket that has these steel and compression stop inserts in it. So we can measure those with a set of dial calipers. We just have to take it and kind of squish it down a little bit. That's about 150 thousandths or a little over 1/8 of an inch. So that makes our oil pan depth about 7 inches. means we have a little over 1/4 inch of clearance, which is perfect. We want between 1/4 inch and 3/8 of an inch of pickup clearance. That way we have proper scavenging and it's not too close to the bottom of the pan, but also we don't have to worry about it becoming unsubmerged from the oil if it's sloshing around. Now the pickup and the pan are matched to each other, and if you have any questions about what you need for your application, you can talk to the experts at Summit Racing Equipment and they'll get you sorted out. But now that we know this is right, we can continue on and get this pan on.
Small amounts of silicone are applied to the corners and edges of the oil pan rail before the gasket and this Moroso 7-quart oil pan with kickouts, baffling, and a crank scraper are dropped on. The pan easily clears our 4-inch stroke and is held down with an ARP stainless steel oil pan bolt kit to seal up our bottom end.
Here in Engine Power, you see us use all kinds of ARP fasteners, and quite frankly, it's because they're one of the best. And when we're doing that, we usually only talk about the fastener we're using for the application. So today we wanted to go over their full line of products and what applications they are right for.
Now, some of you get a lot of questions over what to use in what application. So we have a few examples laid out of what the material is and what application they are used for.
So the first one, starting off kind of at the base of their catalog, is an 8740 fastener. Now for reference, a grade 8 fastener from the hardware store has a tensile strength of around 150,000 PSI, which sounds like a lot. But even ARP's base fastener, their 8740 chrome moly, has a tensile strength of 180,000 PSI, so topping that by a large margin. So they offer this fastener in basically 90% of their catalog. This can be used for basically anything. Most of the fasteners come with a really pretty black oxide finish. This is offered in a lot of their head and main fastener kits, whether you're talking about bolts or studs, and a lot of their accessory bolt kits, whether you're looking for a distributor stud or oil pump mounting bolts. 8740 works great for most applications, but if for some reason you need a stronger or lighter material, ARP can make any of their 8740 kits in any material that they offer.
Speaking of materials, the next thing we're going to talk about are their stainless fasteners. On the stainless fasteners, these have a tensile of 170 to 190,000 PSI. They're made for almost all the same applications as the 8740. Now, it's nice to have the stainless in for a few different reasons. Stainless fasteners have a little bit of an advantage over 8740 chrome moly, not only in tensile strength alone, but in corrosion resistance. If you have a highly corrosive environment, perhaps a marine application, stainless fasteners definitely have an advantage. Plus, they have a proprietary way they polish the fastener, so not only it resists corrosion very, very well, but it looks great doing it. And there's all types of applications for stainless. And again, with ARP, if they don't have an application specifically for what you're looking for, they have an engineering department that can set you up and make exactly what you want for your application.
Yeah, and so the next step up in terms of tensile strength, we move on to an ARP 2000. This is a proprietary material that they have, and the big difference here is that it can be heat treated a little bit higher than an 8740. So this has a tensile strength of around 220,000 PSI. So this is really made for high performance applications, and it's mostly used in main and head fasteners. It can also be used in rod bolts. That's where it really, really shines. If you look at a lot of aftermarket connecting rod manufacturers, they use an ARP 2000 in their high-end, high horsepower rods, and that's because it does a great job of holding up to that immense stress that it has to be put under. So this is per the application, really. It's not something you're gonna throw in your daily driver, but it works really good in racing applications, and it's really common. Things like circle track, drag racing have a lot of high load for a relatively extended period of time.
Now, you're seeing the trend here as we go up in horsepower, as we go up in longevity, as we go up in stress, as we go up in how much this fastener has to handle for whatever amount of time. The materials have to get better. And ARP has gone through a lot of different materials, and they've created some proprietary alloys that work for the application. And that classifies something like our custom age 625 that they use. This is a super alloy that was designed to take not only the highest amount of stress, but the highest amount of stress for an extended period of time. This has a tensile of 280 to 290,000 PSI. Although expensive, it is built specifically for the application. And we can go further from there. ARP, like we said before, can engineer fasteners out of materials for your application. You just have to tell them your parameters.
from backgrounds with things like aerospace and industrial. A lot of that stuff trickles down to the automotive world, and we are simply just benefiting from it. So you know when you're getting a fastener from them, you're getting something that is precision machined. It is quality checked. It is one of the highest grade fasteners that you can get, whether you're talking about their 8740 all the way up to custom made 625 plus or titanium. And that's why we use them so much on our builds, is because it's great having a fastener that has a high quality, that you can trust that it's going to be right every time, and you know it's going to live the long life of the engine. Coming up, we install a high-flowing induction and wrap up our badass baby blue Bullet.
Next up on our 427 small block build is we're putting in the hydraulic roller lifter kit from Summit Racing Equipment. Now this block has a very tall lifter boss, and the lifters themselves are tall, so we have to install them with the cylinder heads off, because if the heads were on, we wouldn't be able to get them in. This is a very high precision, high tolerance, high quality lifter. It's going to work great for our application. We let these lifters soak in engine oil for about an hour just to make sure they are properly lubricated and to help remove any air bubbles from the plungers. Our head gaskets for this build are Cometic MLS gaskets with a 4/165 bore and a 27 thousandths compressed thickness.
The next thing we're going to do is install our TrickFlow 230 cylinder heads we're going to be using for this build, and we're going to be holding them down with a TrickFlow head bolt kit that is manufactured by ARP. And they make specific bolt kits like this for many manufacturers, and we're using it because we know we're going to have the correct dimensions on the fastener, so we have the correct thread engagement and location with our cylinder heads. And these are made of their 8740 chrome moly material. That means they have a tensile strength of 180,000 psi, and they are precision machined and manufactured in ARP's home location in California. Now, to prep these, it's a very specific process that ARP uses, and what we're going to do is take one of their head bolts here, take their ARP Ultra Torque lube and put a fair amount underneath the head of the bolt. Then we're going to take one of their washers, and it has a bevel on one side of the washer that goes up towards the head of the bolt. So we have a nice layer of lube between the two. We're going to leave the bottom side of the washer dry. You do not want to put lube on the bottom side of the washer because it could potentially turn it into a bearing. Basically, when you torque the fastener, the washer will spin, cause the clamp load to go up, and it could damage the fastener or the threads you're putting it into. And then in our application, we're going to put some ARP Ultra Torque on the threads as well. If we're using a stock block where the head bolt holes went into the water jacket, we would use their thread sealant. But there is one correctly prepped bolt. We have 33 more to do, and then we'll be ready to bolt these babies down. These TrickFlow 230s have CNC ported 230cc intake runners, 2080 intake valves, flow over 300 CFM, and have a 70cc combustion chamber that gives us a measured 10.26 to 1 static compression ratio. The cylinder head bolts are torqued in 3 stages to 70 pound-feet. 8 of the head bolts are replaced with a low-profile design to clear our Jessel Sportsman rocker stands. To gain the correct valvetrain geometry, we're using a set of Summit Racing 7200 long 5/16 push rods with an 83 thousandths wall thickness, and they receive extreme pressure lube on both ends.
The rocker bodies are a 1.7 ratio and are installed at 0 lash in the firing order, which is 1872-6543. Then each rocker is set to 1/2 turn past 0 lash for the proper lifter preload.
Beads of RTV seal up the china walls, and a color-matched Edelbrock Super Victor 2 smushes them down to seal up the induction. ARP stainless steel manifold bolts prepped with thread sealer clamp it in place. Before covering the valve train, it will receive a hefty coating of CompCam's valve train assembly spray to properly lubricate them during initial startup. Then these Edelbrock vintage-looking and custom-painted valve covers can seal up the crankcase. A Summit Racing Billet electric water pump wraps everything up until we get into the dyno room. All right, we have our 427 into the dyno cell here, and we've gone ahead and finished out, topping it off with our Edelbrock 850 CFM VRS carburetor, a 1.5-inch 4-hole taper spacer from Wilson Manifolds, and our Schoenfeld dyno headers with a 1 7/8 primary and a 3.5-inch collector. So the next thing we need to do is give this engine some proper lubrication so we can protect all those beautiful parts we just put inside of it. And that's why we're going to be putting Hot Shot Secrets Adrenaline R2 Racing Oil in it. And the reason we're using this is not only because it uses a great Group 4 PAO base oil, but also it has their FR3 nanotechnology in the oil already. What this is a nanoparticle that when you put it inside your engine, it goes through and fills in the minor imperfections on the surface of your engine where all the parts are meeting. And this gives it a nice, smooth surface for an oil film to build, but also it helps protect if there is ever metal-to-metal contact if that oil film fails. Now, what's great about this is you can add it to any base oil you want, not just Hot Shot Secrets. You can put it in any oil, and it does not mess with the additive package that's already in the oil. So we are going to be using their Adrenaline Racing Oil because it already has the FR3 in it. So we have 7 quarts of 5W20 we're going to be putting in this engine, so we have proper lubrication and protection for it.
Now that our oil is all poured in, it's time to prime the engine, and priming is going to be our subject of today's Summit Tech Tip. Priming is very important because we don't want any of our new parts in our new engine having metal-to-metal contact on initial startup. So we prime the system. We can do that a couple of different ways. The first way, if you can't physically turn the oil pump like in an LS or like a Coyote, is we use a pressurized tank. What we'll do is we'll take the capacity of the oil system, put it in this tank, and then pressurize it with air up to around 100, 120 PSI. Then we'll take the hose, hook it to an oil gallery, and then physically open a valve, and that will pump the oil through the engine at pressure. Now that's a great way of doing it, and you also turn the engine over while you're doing it so it gets oil everywhere where it's supposed to be. Another way of doing it, if you can physically turn the pump, like the distributor that turns the pump, you can get a shaft that goes into a drill and you can physically turn the pump and pump oil through the system. Now this particular one is for our small block Chevy because a top for the distributor and a section at the bottom that completes the oiling circuit just like the distributor does. It is important to turn the pump in the same direction as the distributor. Otherwise, you turn it in reverse, it will aerate the oil, it will not pressurize the system. This way, you can turn it, pressurize the system, turn your engine oil, make sure oil is getting everywhere, and that will help your engine. If you have any questions on how to prime your engine, contact the experts at Summit Racing, and they'll get you set up. While priming the engine, we'll also turn it over to ensure oil flow to every part of it. Then, this Phytech dual pickup billet distributor can be installed and timed before the Phytech ceramic boot wires can be connected to our spark plugs.
All right, we have the 427 running on the dyno. We're going to start relatively conservatively on timing. I've set the total timing at 30 degrees, so we have a locked out distributor. We're just going to start there, and we'll work our way up probably in tune for the timing. The carburetor so far seems really, really close, so I didn't have to touch the idle circuit or anything, so we'll see how close that is and go from there.
All right, so first rip, we're gonna go from 3,500 to 6,800. Something like this, street, pump gas, kind of familiar with this type of head, this type of chamber. There are some unknowns on here, so there's only one way to find the unknown.
Should have both peaks in that, so we'll see what it does, and then we'll tune from there.
All right, here we go.
Go for it.
Load's nice.
Yeah.
Sailed right through her.
That carb is right out of the box too. That's like right there.
That carb is nice and tight.
Okay.
That's not bad out of the box right there for a start.
Yep.
515 pound-feet, 588 horse.
Yeah.
I think we picked the right RPM because you can see it's just barely tailing over.
And it's got very little timing in it, so it's a little notchy, but that'll smooth out once we get a little timing in it here. But let's see. Oil pressure is nice and good, peaking at 70, we'll call it 79 basically.
Yeah. This rides a bypass the whole time.
Yep. Torque is, peak torque, let's see here, is right at 5,200, and peak power 6,500. That's a pretty good spread. I'll take that for a street engine.
Nice spread.
And
here, if you look at the brakes.
Yep.
Brake specific is super consistent. That is super nice. Timing, fuel, not really fuel, but
I think it's close,
the typical thing that we do with engines. Montage. All right, after our normal stuff that we do, which is fuel and timing, mostly timing on this one because the fuel was right on the money. The Edelbrock carb is doing pretty well out there, so we ended up just doing our own thing, jacking some timing in it.
Yeah, I mean, our small block combos pretty much always 36 degrees. So,
That's just what it is.
That's just what they like. You go past that, they start to run on really hard when you shut them off. They don't really pick up any power, so there's really no point. So,
especially pump gas stuff.
yes, I mean, pump gas is always, as we say, the limiting factor.
That is the biggest wild card because it came out of the ground. God knows what it is, but hey, let's see what our final iteration is, and we'll see what kind of steam she makes here.
Go for it.
Ready? That sounds nice. All right, that's the heat right there. 530 pound-feet of torque. All right, we'll take that.
Yeah.
609.3 horsepowers.
That's a pump gas street engine, hydraulic roller.
Yeah.
I mean, that's solid. I mean, anything with 600 on the street is already a little sketchy, kind of fast, right? Depending on what car it's in.
People get so jaded with power numbers because everyone with a little bit of power add or any sort of artificial atmosphere, like, well, my Honda with a turbo on it makes that. Well, I'm sure. Put a turbo on this one, how much would it make?
Yeah.
Right?
Well, and also, I mean, naturally aspirated is making 530 pound-feet, right? Which is a solid number, and this will go in literally any spot that a small block Chevy would. You could put this almost in anything, and it will rip. And not only that, but it looks killer. I mean, I love that color that we came up with, that baby blue look.
Oh man,
with all
I think
the polished aluminum and stuff.
That's spectacular.
And I mean, everything looks good. Vitals look good. Oil pressure's good. It's got vacuum going up in the crankcase, so we have a good sealed engine with that block that tells you the bore's nice and round and the surface finish is right.
Hats off to Summit on the block because it has a very rigid cylinder. Case in point, it's sealing up really nice. Everyone has done their homework, I think including us, so I think we've got a really nice pump gas street bullet. So,
man, it's gonna look good in anything.
Grenade success. To find more cool builds like this one, check out Engine Power on Power Nation.